more authentic than those online tests for various reasons that we've already talked about. So be authentic about what we're doing behind the scenes here, making sure, like I say, we're doing the right thing, which is best for you. I don't know why for there I could delete that, but prove I'm here and it's me and I'm in my basement, blah, blah, blah. Quarantine, I guess. Okay, so again, give you a chance to still keep writing if you are behind. Mrs. Fasola loves telling me about your vocab as we move on. Many of these words we've already used. Dilation, that's a stretch or shrink. And that's why I have that A, B, C, D, just to prove that we've had these words before. Center of dilation is going to be new. It's going to be right off the bat what we're going to be talking about. Scale factor is going to be huge. I don't think that was in our quizzes yesterday. You'll hear that word today. It's just the amount of how the situation is shrunk or stretched. And actually, I could say that word in A, B, C, D if that comes up that you see in front of you. Told you this yesterday. The pre-image is the original image. The new image is just called image. I don't like that. I almost want to call it post-image or new image, and I'm going to keep saying that, but the semantic, very detailed math teachers say, no, that's only called the image, not the new image. So that's what we're doing. We're taking images and we're changing them. We're going to have to construct them. Today is like a geometry thing. Sorry for the big switch, but you had 2 weeks off. You probably forgot about all the stuff we did last semester. That's good. We have a clean slate now. Okay, brand new stuff, and you just got to follow along, and nothing's really connected from what we did before. Some things we'll definitely be solving equations again in a geometric sense. Trigonometry is coming up. I love it. My favorite situation to teach. So Katoa. Similarity, we're definitely going to have some similar figures here and talk about relationships with those. Remember what I told you about transformation? That is the general term for translation, dilation, reflection, rotation, those kind of things. Composition's more 9-2. Mrs. Fasola put the notes together in the past. We're going to have to break it up. Similarity transformation, we'll talk about that later. Rigid, enlargement and reduction is kind of what we're doing today. But this is just a little bell work, and if I was going to do the normal things, I'd be calling on the students. What is y equals negative x squared, and how is that different than y equals x squared? Hey, put it in the chat. Let's do that. Get those that want to participate and put those things in there. Go for it. Good. Reflection over who, though? Everyone, I got 4 people that put reflection in accordance of the, there you go, reflection over the x-axis. Good, love it. Love your enthusiasm and getting that in the chat. I truly do. So it is a reflection, and that is one of our words up there. So we are going to reflect, not today, reflection over the x-axis. Okay, let's go to the next one. What's the vertex? Let's put it that way. And then we can, the letter B, what's the vertex of this parabola? We should know this is parabola. We did a whole chapter on graphing. Good. But really what that means is we went 2 right and 5. Remember, opposite on the inside, -2 means 2 right. -2 should be left. That's what I mean by opposite. And +5 is 5 up. So yeah, the new vertex is 2, 5. That means you went from 0, 0, 2 right, and 5 up, 2, 5. Those are translations. When you slide, that was in yesterday's quizzes. So translations is what that represents. Hey, what's the 3 represent? How do we put that in a math sense? Ooh, look at that. Stretch vertically. Carolina was ready to go. So was Matt. Vertical stretch. Good. There was vertical and horizontal stretches. The horizontal stretch is kind of harder to see. I think we talked about it a little bit. Vertical stretch by a factor of 3. Did they look at that? Carolina and Matt used the word factor. So no, it's actually a stretch, Cecilia. That's okay. I appreciate everyone putting in their it means you're aware and activated. Your brain's moving along here and connected with the notes. Vertical stretch by a factor of 3. That's actually called a dilation. I think maybe I used that term, but maybe I didn't. To dilate means to stretch or shrink an object. So do denote that as a dilation. All right, and then don't worry about the chat on this one because there's a lot to write about this one. This is a reflection over the x-axis. And so it's all bad, Matt's like, forget it. I already had it ready to go, Miss Stress. I love it. Reflect over the x-axis. Nicely done. I should almost steal your chat and just put it in the. Yeah, let me try that. This is funny. Can I get that? Oh, I can't even get over there. There you go. I'm not gonna put your name though, Matt, because then you could sue me because we're let's see, paste. Let's see how this pastes. Ow. Well, that was Matt's little writing there. I just hate how this does this. I can't get this. Oh, I can't. Matt, you're getting full credit. Why does he do this stuff? I don't know. Just to have fun with things and give someone credit that deserves it. Okay, vertical shrink by a factor of 1/3. This program is so bad. It's so hard to deal with. Not very user-friendly. Nice, Matt. Hopefully you appreciate that I did that. Right? Cool. I just love it. So don't put it in the chat. And he goes, you know what? I already had it ready. So reflect over the x-axis, vertical shrink by a factor of 1/3, left 5, 2 down. Everything's perfect. So we have a reflection, a dilation, and a translation, right? I do like to look at it that way. All right. Okay. Now, for those that didn't print, fine. How many people did print? Just raise your hand that I could see in the chat there. Okay. The only reason I wouldn't want them to print, so hopefully you can visualize this. When I make this construction and those that didn't print it, just follow along with what I do. So you're going to create the image as we go. And this is kind of weird. I don't know how I'm going to test this. I might. Again, we have class kick. This is making a construction. I'm blabbering right now to give people a chance to write these 4 steps down, by the way. We used to, back in the day when I taught Math 2 regular, about 4 or 5 years ago, I can't remember, we used to drag out a compass and a protractor and actually make major construction and measure angles and then make extrapolation from that. And then talk about theorems, why they are what they are, or postulates, big geometry concept. But now this is just kind of like a very reduced down, making a construction kind of idea. And I'll let you eyeball some stuff. It does say measure in step 2, the length of each segment. I don't know if we're going to be getting out rulers. I'm not going to be making you bring rulers to class on our first day back where we're going to take a test and I might have a question like this. We can eyeball it and actually talk about that as we go. Okay, and don't feel bad. I know when you're writing down words for steps, you don't know where those words are coming from. It's hard to make a connection. So I'm giving you a chance to write them down. Then I'm going to go ahead and follow step by step this method 1 of dilating a picture through a construction. Okay, so step 1, draw rays from the center of the dilation to each vertex. This is to the pre-image. Remember, pre-image is the given. And then when I show the stuff that we have here, I'll show you what will be given as I draw over it and trace over it. Measure the length of each segment. You can eyeball it. Apply the scale factor to each segment length and label each vertex with a prime. Now this is where notationally you need to understand what is the pre-image, what is the image, which is what I would like to call it, but this book just calls it the image when it's done. Connect consecutive vertices. Okay, let's see what that means in an actual drawing. Is everyone done writing this? You non-note taker or your non-printers, right? Done writing the 4 steps? Okay. All right, so now don't try to write all of this at once. Okay, those non-note takers. Okay, here's what would be given. You're given the pre-image, which is triangle A, B, C, D. On your notes, try to draw very similar to what I have here, or what is given in this question. But try to draw that triangle. I don't like that last thing I just did there. Here we go. And then here is the center of the dilation. And to be honest, this could be just about anywhere. So if you had to create your own center of dilation, it's wherever you want to put it, to be honest. Because your new image will still look, based off of your measurements, pretty spot on to what this image looks like. You just have to believe me and trust me on that. But the more distance you have, especially in doing a scale factor of a half, then you have maybe a better chance. Maybe not really long distance. Give yourself some space. But this is given. So given and given. So that's what you'd have on my test. Then I would say draw a new image with a scale factor of a half. So here's what these words mean. Measure the length of each segment. Not really this segment, it's actually this segment. We want to measure the length of each one of these and how long these are. But do we really want to? Do we really want to get a ruler out and spend that time? So say we did. Say this was measured at 4 inches. Well, then what you want to do for a scale factor of a half is cut this in half and measure out 2 inches and 2 inches, and then that's where B prime must be located. I think you can do that by eyeballing it. I don't think you have to measure at all. I think you could look at the length of this segment and reasonably cut it in half, and then that's where B prime would be located. All right? And that's what I think realistically we can do, if that's okay with you. Okay, but say you got your measurements out and you found this to be 3 inches. Well, then you want to go 1.5 and 1.5. That is half. And then that's where A prime, I should be going red. So in red, this is what we would be doing. I should have put these in red. I think you don't need to measure. I think you could look at this segment and visually cut it in half yourself without getting a ruler. And then I think you can take this segment and cut it in half without getting a ruler. And then the last step says connect the vertices that you just constructed. I want to erase this because I don't want that. I want this like your work to be what you do in red. So this is what you would have done in red. You'd have done this in red, or you would have, this is your work, and then you would cut those segments, dotted lines, in half, and then draw the new vertices. Now this is why I like the next method in a combination of the two. I kind of like the next method a little bit better after going through the notes last hour. And I'm going to be honest, by the way, this construction's all fine, but there's some notational weird things in this book that I've never seen before in another book. And I've spared you of that as of right now for today. Just wanted to kind of talk about this dilation thing and this construction, and then relationships with similar figures. And then, I don't know, maybe look for something tomorrow, possibly. If not, I'll put a note tomorrow that, either or, look for something in the calendar tomorrow. I'm kind of a little leery about some of the things in the book, and do they really translate to things later? Thinking about you and our environment, and what's important. So I'm kind of like knocking around and haven't had a chance to talk to the other teachers about that, but just keep that in mind. All right, but anyway, one more thing to note, look at that. Those are primes. They look like little tick marks or apostrophes, I guess. And that means that triangle ABC is the original pre-image. Triangle A prime, B prime, C prime is the image, the new, scaled down by a factor of a half. Okay, now I'm going to emulate this next one. Again, it's up to you to be professional over there. You know, I know I'm not calling you out here and answering questions. That's why I love to chat. Those that make mental notes that I see that put in the chat all the time. Some people haven't put something in the chat all year long, right? Again, your education is really up to you, what you do. All right, so method 2 is the parallel method. And I like the combination of the two. And I'm not going to know which method you use. We're just giving you 2 possible choices here. That's really all that matters. It's not like you're going to be tested on both. When I do the next couple of constructions where it's an actual example, I kind of combine the two. And actually, I can look at our previous thing and show how the parallel method can be kind of checked with my drawing here. So same step, draw rays from the center of the dilation to each vertex. That's usually given. And so is the pre-image. Usually the center of the dilation is given and the pre-image. Measure the length of one segment. That's one of the dotted lines connecting the center of the dilation. One of the vertexes. Measure the length of one segment, and then step 3, apply the scale factor. Very similar, but you're only doing it for one of them. Then draw a segment from the prime vertex that is parallel to one segment of the pre-image and keep. So again, try to follow along what's given, and then the order that I do this, even though everything is thrown at you. But I'll pause, let you get a chance to write these steps down if people like steps written in words and then follow them. Realize I have an image of cards right there. I want to inspire gambling. Dartboard's okay, right? Oh, there's another. There's the dogs playing poker. Anyone ever see the dogs playing poker classic sign? No? Nobody? Bummer. Thought that was like I remember that as a kid. Thought that was a famous picture. Okay, I think I've stalled enough. Everyone done writing? Okay. I love that. You see how you see me? Look, you can see my shirt. You can see the top of my head. Why are most of you like this? What is going on when I could just see, like, I got your forehead memorized, not your face. I don't get that. Anyway, I'll just move on. I'll leave you alone today. Okay, so don't write it all. Here's what's given. What's given, I'll write in black and I'll trace over. So try to draw, you note takers, the ones that didn't print, which is good. Good. I randomly lose my pen all the time. I just lost my pen right in the middle of writing. Love this. Okay, point. So try to draw a, I almost said parallelogram. No way. This is just a general quadrilateral. I don't have parallel lines here. Sure, Brian. That's given. And then this is a weird center of dilation point. Now, my thinking is that Q is farther away. See, it's hard to, but I guess you could look at it either way. It's either farther away or it's either closer. It's hard to imagine 3D on a 2-dimensional screen or piece of paper. So I first imagine that Q is farther away, and then this is coming towards me. I'm just trying to get you to spatially think about, what is happening here when we're doing this imagery here. I guess you could reverse this and think about Q being closer to you, and then these arrows are going away from you as well. That's what's so tough about 2D and 3D, trying to imagine the two. All right, so that's all that's given. Wrong. I should have done this in red. My bad, dogs. I should have drawn these dotted lines in red, implying that whatever I do in red is what I would be doing to do this. So in black, given. In red, this is what you start off with. Here is the segment from here to here, but I'm going to keep going as far as I can. So this is what you'd have to do as a construction. Keep going with these dotted lines through the vertices and continuing through. think maybe do this, you know, 1 or 2 times in a class kick. I can do this on a class kick and see what your image ends up being and judge it. You know, have you shown the scale factor correctly? By the way, I kind of skipped over that. We are doing a scale factor dilating by a factor of 2. So here's emulating the directions. Okay, I measure this. I measure this from here to here. Let's just make it easy. Let's pretend we did have a ruler. We found that to be 1 inch. Well, then what I want to do is keep going past this 1 inch more. I think you can visualize that and not have to measure. I think you could look at this and say, all right, this is about this far. I want to go the exact same distance that far away again and denote W prime. That's what I want to do. Okay, so that is taking one vertex and dilating it by a factor of 2. And now at this point, from this vertex, I want to draw a line or segment that is parallel to WX. Parallel, 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 stop. That's why you have to have that dotted line out as far as possible so that you can see where that segment ends. So look at my previous image. This is why I'm going to do a combination of the two. If I did the first method, these should definitely be parallel. These should definitely look parallel. And these should definitely look parallel. And if they do, then I did the first. That's why I like a combination of the two. And I don't really care which one you do, but that parallel situation should be in your construction. That's why I like this method as well. It really makes that idea perfect. Okay? So I want this to be parallel. So I go and draw this until I hit the next dotted line. And then that's where Y prime is. Again, knowing that Y prime is the new vertex, that prime means it's the image, the new. And then you connect the last two together. Right? So I only measured one segment. I doubled because of scale factor of 2. And then I used parallel as an idea to make sure the new image is a scale factor of the previous image or pre-image. Okay? One or the other, couldn't care less which one you use or a combination of the two. Oops. Oh, from Google Meets. Okay, that was when I took Matt's answer and put it in the notes. All right. Write these down and give these a try. I'm going to turn off the chat, and then I'm going to go back in and show my answer comparative and see if you can do this. Okay? Notice in letter D, the center of the dilation is way off to the left, upper left corner. Again, hopefully all of you are in tune with this, giving this your own try. I couldn't care less what method you use, but I am going to use the methods accordingly. But we will use method 1 on the first one, method 2 on the second. I think on the second one, I'll get it started and then turn it back on and show you what we got here. Okay, in about 10 seconds, I'm going to stop presenting because I'm expecting you at home trying these. If you don't, you get upset, students that don't sit in there. Netflix. Cool. Also trying to take attendance. So really giving you a chance. Finding out that my TV, maybe I need my glasses. TV pixels are not very good. Computers. Hurry. Oh, I already took attendance. No, I didn't, did I? That's weird. Sorry. Wow. Crazy name. Okay, I'm gonna stop presenting. Right, and I'm doing the work on my own. I'll go super fast. Take my glasses off. I can't see the screen anymore. My full screen. Ooh. 1, 2, 3. Ooh, this one's a big one. Kind of leaked into the other one. 1, 2. Ooh, I'm actually using my thumb to measure from R to L, and it's almost from my knuckle to the tip of my thumb. That's how far R, according to my screen. Depends how you drew it. Then I do knuckle to end of thumb again, knuckle to end of thumb again for RL compared to RL prime. And then I'm going to check that parallel situation when I'm done with this method C here. Okay, so R to J is my knuckle of my pinky to the end of my pinky. So then I do that 2 more times. Straight edge might be helpful. Even on the screen, I think you could put a straight edge. And that's pretty close. Then I'm going to check if they're parallel when I'm done. Pretty good. I'm not going to make you get a measuring tool, but I am going to present again because I gave you enough time. I double checked my attendance and I can't believe I forgot that I did do attendance. Okay, present. Practice for sure. Okay, so there's my first answer. And it should relatively, so 1, 2, what I should see is 1, 2, 3. 1, 2, 3. 1, this is the tough one. 2, 3. The R to L was kind of far away, so I ended up landing in my other example and getting that drawn out there. But anyway, hopefully that's what you have on this. This is why I left this one go, because I'm going to go ahead and do this one super fast. But I was just giving you a chance to get the example written, get the picture written for those that have not printed the note. Completely okay. Going 1/3, I think I can eyeball this out. 1/3, 2/3, 3/3. This new point should be right here. I'm going to call that Q prime. Now I'm going to do the parallel thing. Okay, so from Q to P, that would be this. And I just want to make sure that this is parallel, kind of, sort of. And then this should be P prime, right? And then parallel to this one would be what would get me R prime. So kind of going along with this. It's not perfectly horizontal. It's kind of okay. I think that's all right. R prime. Then I connect these and just make sure the last. Holy crap, I did something completely wrong. What did I do wrong here? Because that is not even close to being parallel to that. So where did I go wrong? Maybe this one? Oh, this is embarrassing. Okay, so let me see. Q to P, P to R prime. And then how did I get so far off on this one? Too far. Let me use a measurement here. Thumb, thumb, thumb. Kind of close. Oh, it worked out so well the other hour. So this would be from here to here. Let me see if this would be, maybe this line is not straight enough. Am I cheating by doing that? I don't know. So I guess I ran into a problem with that line not being straight, right? Because now that kind of looks like it's parallel. So I'm kind of glad that this I ran into this problem, because look at this drawing. I know I'm okay because these look parallel. So even though I did the other method, checking the parallelness of the new image needs to be taken care of. So I kind of had to make an adjustment in this line. I kind of wavered in drawing this dotted line. So maybe using a straight edge is kind of important in this, or at least making sure that your line is straight. So I don't care that that happened in the video. This is how you make an adjustment. Right? When I connected the last 2 points, RQ was not even close to being parallel. At least now it looks like it is, and then I would grade the students as correct. Okay, so glad that I have everyone okay with their drawings. You do okay on your end. On a piece of paper, even a straight edge, maybe your ID would work because the paper is so small. Any straight edge would be a good idea. All right, let's move on. I like this because this really talks about similar figures. So those that don't have this written down, I'll give you a minute. That's the only reason why the note's taking a little bit longer, but that's okay. Probably if we were in school, I would have printed these for you just because there's a lot of images. And then the constructions would go faster. But it's nature of the beast. It's what we have. That's why things take longer. You ready to ask this? I guess I could ask this on the next. Okay, so rectangle A prime, B prime, C prime, D prime is a dilation with the center P of ABCD. Determine the relationship between the angle measures and the side measures of the pre-image and image. I'm also going to bring up those that have this written or printed. What is the scale factor? Be careful. Usually we want the scale factor for what created the image. So from pre-image to image, what is the scale factor? And I do want to wait, as I know people are writing this down. Tough to get a coordinate plane. That's why if you have graph paper, heck, I have some CAT students that's how they turn in their written work. They use graph paper all the time because it also keeps their writing structured. But then when a graph comes up, then they have the graph paper ready to use. So not a bad idea, but I know it's kind of hard to do the graph paper writing these two images down. But it's actually not too bad. And don't answer this yet, but from P to A compared to, let's do it this way, from P to A compared to P to A prime, hey, put in the chat, what's the scale factor? By just looking at those two distances based off of what I showed you before. What is the scale factor? Ooh, is he right? I would say so. So the scale factor actually is this, and then this really is going to equate what is the relationship between the sides of the pre-image and the image. The scale factor is, well, this distance is 1, 2, 3, 4, 5, 6, whereas this image or distance from P to A is 2. So this is a scale factor of 3. We're going to see that with the side measures. It's kind of harder to do with this. What's the distance from PB compared to P to B prime? I can't count that. That's a slanted line on a coordinate plane. I need the distance formula, or I need to get a ruler. So it's hard to see that 3 ratio with those. But not here. When we go horizontal or we go vertical, it's easy to count on a coordinate plane. That's the value of a coordinate plane. Well, here's another way of looking at it. Looking at this coordinate plane, I'm going to zoom in on this. This has a length of 2. This has a length of 3, 2, 3. Counting here, this has a length of 9 and 9, 6 and 6. So what is the side relationship? The sides are not equal. They are what's called, I don't want an equal sign there. They are what's called proportional. This is huge for similar triangles when we deal with those next week. By the scale factor, which is 3. That's why you got to be careful in, which way are we looking at the scale factor? And it's usually from pre-image to image. So the way we have to write this is as a proportion appropriately. A prime B prime divided by AB will be congruent or equal. I'm sure you've seen a congruent sign before. I think when I don't put the symbol there, it should be equal. That implies the measure of AB compared to A prime, B prime. And then any of these, like BC, B prime, C prime, BC is equal to, I'm going to keep going, CD prime, CD, and we're left with A prime, B prime over AD. All of these proportions would equal 3. So A prime, B prime, 9 divided by 3, 3. BC prime, BC, 6 divided by 2, 3. 9 divided by 3, 3. 6 divided by 2, 3. So that's the relationship in similar figures. The sides are proportional. Again, it's taken a long time to kind of look at this, but that's what a construction does. Imagine if we had protractors and compasses and had to do those measurements, it would take 3 times as long for these ideas to come out. Okay, but then let's look at the angle measures. What are the angle measures? What's angle A compared to A prime? Angle B compared to B prime? C to C prime? And D to D prime? Put it in the chat. Don't tell me what the measures are. Tell me what the relationship is. What is angle A compared to the angle prime A? So angle relationship. Nobody's going to put it down. I think I saw something bling up there. Equal, same, right? And then that's going to be true with corresponding angles. These are called corresponding angles. Not in this another sense. There's another term with corresponding. Are congruent. So angle A is congruent to angle A prime. I know they're all equal because they're all 90. But when we get the triangles, the angles that correspond to each other will be equal whether they're right or not. Lost my pen randomly. I love when that just happens right in the middle when I'm writing. And then comma, dot, 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 dot. I think we get the point. So in similar figures, you want to write this down. Similar figures, whether they're rectangles or whether they're triangles, no matter what they are. The angles are equal, the sides are proportional, right? And then that's going to hold true next week when we talk about similar triangles and some other relationships there. Okay, moving along, we do have 14 minutes, don't want to have to go the whole time. Probably over-exampled a couple things. I did want to give you one little notational thing. I guess this is one that we could just kind of skip over and just look at it. Center P, determine the relationship between angles and side measures. I think we've already decided that. But what is the scale factor of this one? Go ahead and put that in the chat. Just tell me what the scale factor of that is. Remember how we have to write that. The scale factor is in terms of how did we get from the pre-image to the image? Like it, 1, 2. I think when some people put it in and some people are about to put it in, like, oh, all right, I didn't make it. Got 3 people with 1/3. This is a length of 2, 1, 2, 3, 4, 5, 6. This is a length of 6. But from pre-image to image, we went smaller. So I did say this last hour, and I forgot to say that in this hour. When the new image is smaller, then the scale factor is less than 1. So 6 divided by 2 is 1/3. Okay, so do understand that. If the new image is bigger, then the scale factor is bigger than 1. Very simple concept. All right, and then it's the same thing. Side measures are proportional, angles are equal. We happen to have rectangles again. I know all of the angles are equal to 90 degrees, but just keep that in mind even when we have triangles. Matter of fact, we have this one real quick. I don't know if you even have to write this at this point. Tell me what the scale factor of this one is. Remember, there's really only one right answer. You want to go in terms of how did you get from the pre-image to the image, right? Want to verify and agree, or do you have a different answer? Ooh, tough call on me. We should have a protocol for putting in the chat. put it in your chat, but don't press enter until 3, 2, 1, and then boom, and then I see a whole bunch of blah, 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 right? And see maybe we'll try that in the future. Good. It is 3 halves because it is new image divided by pre-image. I keep saying new because it just drives me nuts not to see. And then I'm surprised no one put this last hour. They said 1.5. It's the same, right? So yeah, that's really the crux of it. But I will say this, mark this down. These are not 90 degrees. I guarantee you that angle L prime is equal to angle L. And one way you can mark angles as equal is with tick marks in the arc. And I guarantee angle K prime is equal to angle K. So angles are equal, sides are proportional. J, 1, 2, 3, prime, sorry. J, 1, 2, 3. This is how you mark angles congruent. There's another way, which I'll show in the next one. 1, 2, 3, 4. I destroyed end there. All right? So that's another way of marking angles congruent. And I think this book uses that notation as well. So, all right. I don't think we need to know. I think that's fine. I do want to say this, though. What's the scale factor? Wait, don't put it down yet. Okay, don't put it down. Don't press enter. Do not press enter. Do not press enter. Okay? So get ready in your queue in the chat. What's the scale factor? And then when I go 3, 2, 1, 0, press enter. 3, 2, 1, 0. Emily. Oh, that's awesome. I think Emily hit enter too early. All right. All right. Excellent. Good. I got, holy cow. That was the greatest thing ever. I think I got like 20 students that put a half. So tells me a lot, and it isn't too bad. So I just picked one set of sides. That one's a length 4, that one's length 2. Now I will tell you this. Angle A prime is definitely right. So is A. So yes, those are equal. Now we finally have non-right triangles. Or I'm sorry, non-right angles. But I guarantee those are equal, and I guarantee those are equal. And I'm showing you a different way to show equal angles. I think the last one I put tick marks in there. So sometimes it's the amount of arcs that you put there. Okay? Now I just have one last thing to show you. One little notational thing, which is something I've never seen before in my life. And then it gets a little bit crazier after this. This is why I want to talk to Mr. Stronowski about what do we really want to talk about notationally? And have we ever seen this before? This one's not so bad. So it says determine the coordinates of the vertices of D3 of triangle ABC. And it just says this right here. D3 means the word dilation by a scale factor of 3. So that's the first weird notational thing I have never seen before in my life in any other math class. So we're just going to go with it. Maybe this is something I've never taught before, but I just feel like this is unique to this book, this notational thing. So sometimes mathematicians get lazy and don't want to have to write, do a dilation by a factor of 3. Let's turn it into a symbol and say D3 of ABC. That's a lot of times what math is. Okay, but you understand that it's the origin that is the point of the center of the dilation. So you'll get this picture. And this one was kind of pain. I did this last hour. But this is the origin right here. And this is the center of the dilation. And for me to do this by a factor of 3, well, one of them is not too bad. 1, 2, 3. So from the origin to C, that's a distance of 3. So I have to do another 3. I'm already off the scale. And another 3. And then that's where C prime is. There's going a factor of 3 for that. Right? But then I might want to do the parallel thing at this point. But the problem is it is still going to go off the scale here. So I have to really, so I think on this one, that's probably what I would do. I'd do the parallel one. But I draw this out as far as I can. Ooh, this is going to go like into the words. I draw this out as far as I can. Remember my mistake earlier in the notes. Make sure those are straight. And then I'd probably try a parallel situation. That looks parallel. Whoa, hello. That looks parallel, so I could call that A prime. Okay, so trying to get parallel to this one. Woo. Ooh. That's not too bad. and then connect the last one to the triangle. Ooh. Straight edge would probably be nice on this one, B prime. So I took C and I tripled it, and then I used method 2, which I kind of feel like I'm liking that one better than. Okay, we don't have time for that one. That's a similar thing. B 1/4. So from the origin, we were going to take 1/4 of this. I'd probably go with point R first. Oh, look at that, -4. So I know -1 would be 1/4 of that, and then do the parallel thing. So coordinate planes can be nice with that, but just a notational thing I covered there. Okay, 11:14, I think I'm good. I'm going to stop the video. Don't leave yet, but let's get that. Ooh, I don't even know what I'm doing here. Where is the, there it is, screencastify. Okay, stop.